Hello everyone. This video is going to show one visualization of complex uh, multiplication over imaginary quadratic rings or fields. There's a lot to show, so I'm going to get going right away. First of all, I set up two vectors because I need a little preparation for this one. It's going to take a little longer. So we'll get started right away. The first thing we're going to do is we're going to take the magnitude of these two vectors representing our complex numbers. Then we're going to take the angles that they make with the origin. I'm sure most of you are familiar with this particular visual interpretation of complex arithmetic. And then the angle for the second one with the real axis. Okay. Then we're going to, let's move this around so it's a little bit easier to see. They yank it away from that. Okay, that's good enough, I think. We don't have a lot of time. We shouldn't be doing that. Okay, and then we're going to, first of all, we're going to multiply the two magnitudes. Okay. Up here, we're going to put that figure right up here. We're going to add the two angles. Okay, fine. And then what we're going to do is we're going to do a measurement transfer onto the real axis. If someone could think of a better or an easier way to do this, let me know. This is the only way I could think of in Cabri onto this axis. See it right down over there. Then we're going to take a vector from the origin along the real axis to this point. Okay. Then we're going to rotate this vector around the origin by the sum of those two angles. Okay. Now we can go up here and we're going to find the coordinates of that point. And we see it's 224. Now, since we don't have a lot of time, I already worked out the calculation to demonstrate to you. 5 plus 2i and 2 plus 4i, as you can see the calculation is worked out. It works out to 2 plus 24i, which is what we got up here. Okay. Not much more to say about that. We'll go on to the second one. This is going to be z of 2i. Okay. And we'll do the same procedure again. We're going to take the magnitudes of our two vectors representing our complex numbers. And we're going to take the angles they make with the real axis. If it was below here, it would be a negative angle. Oh boy, don't have time to get into that right now. Maybe I should have given an example. Well, it's late now. If any of you have any questions about that. Angles, as far as all this is concerned, that go down here, they're going to be negative. Okay. Now what we're going to do, of course, is we've got to calculate again. And take the first magnitude, multiply it by the second magnitude, or absolute value or modulus in complex number terms. Okay. Up here, we're going to take this first angle, and we're going to add it to the second angle. 70.5. Take that angle measure, put it up here. And again, we're going to do a measurement transfer of this number, the magnitude of the result, onto the real axis. 18.4. Is that? I think that's it right there. Yeah, I think so. Okay. And we're going to define a vector. We'll find out soon enough from this point to that point. Then we're going to rotate that vector by this angle. Oh, around this point. There we go, sorry. And then we want to find out the coordinates of this point that it points to. And it's 213. Again, I've worked out the calculations. And you can see 6 plus the square root of negative 2 times 1 plus 2 times the square root of negative 2 equals 2 plus 13 times the square root of 2, which is indeed what we got. Okay? So it seems to work out in 3 mod 4 quadratic ring. Now let's try a 1 mod 4 quadratic ring. This is z, the maximal ring of integers, we'll put it that way, of z of the square root. Well, the maximum ring of integers for q of -7. Well, I think you guys know what I mean, I hope. I'm saying it somewhat right. We're going to take the magnitude of this vector, or the absolute value, or modulus in complex number terms. We're going to get the angle of these two that they make with the real axis. Boom. Alright, then the angle the second one makes. Boom. Boom. Okay. Then we're going to calculate this magnitude times this magnitude. Okay. We're going to put that right there. Then we're going to take this angle and we're going to add it to this angle. And we get that angle there. Put that right there. And again, we're going to make a measurement transfer of this onto the real axis. Okay. We're going to define a vector from here to that point. Right. We're going to rotate this angle around the origin by this angle. Okay. And we're going to find where it points to. We're going to get the coordinates of the point. Okay. It says -6, 14. Okay, you can see I worked out the calculator. And there's a little bit more involved. Again, I'll have to reference that paper that I gave you how to do this multiplication, the arithmetic and stuff. So you have 6 plus 2. I'm just using that, I don't know which alphabet that is, to represent the principal surd in this quadratic ring. But you see the answer we come up with is indeed -6 plus 14. You see the arithmetic I used. So you can check it yourself, and you see we got -6, 14. So it works for z of I. It works for 3 mod 4 and a 1 mod 4. So I'd suggest probability is, of course, very high that it'll work for all of them.